In this problem, we want to solve for m given 2 raised to power m plus 4 raised to power m plus 8 raised to power m is equal to 39. I'll start by repeating the problem. This is 2 raised to power m, and then 4 raised to power m I'll express as 2 raised to power 2, then raised to power m, then plus 8 I will express as 2 raised to power 3, then raised to power m, equal to 39. I'll open up this bracket using this law of indices. X raised to power m raised to power n is equal to x raised to power m times n. Also, this is equal to x raised to power n raised to power m. Using this rule, this becomes 2 raised to power m plus 2 raised to power m raised to power 2 plus 2 raised to power m raised to power 3 is equal to 39. I'll represent 2 raised to power m by another variable, say x. Therefore, this becomes x, then plus x squared plus x raised to power 3 is equal to 39. So I'm going to have x plus x squared plus x raised to power 3 minus 39 is equal to 0. I can separate 39 into 27 plus 9 plus 3. So the equation becomes x plus x squared plus x raised to power 3 minus 27 plus 9 plus 3 is equal to 0. X plus x squared plus x raised to power 3 minus 27 minus 9 minus 3 is equal to 0. X plus x squared plus x raised to power 3. 27 here is 3 raised to power 3. 9 here is 3 squared, and then minus 3 is equal to 0. Let's rearrange this question into x minus 3 plus x squared minus 3 squared, then plus x raised to power 3 minus x minus 3 raised to power 3 is equal to 0. This right here is difference of 2 squares, and this is difference of 2 cubes. For difference of 2 squares, when you have a squared minus b squared, this is factorized as a minus b times a plus b. And then a raised to power 3 minus b raised to power 3 is equal to a minus b, a squared plus ab plus b squared. So using this to factorize the equation, this would then become x minus 3 plus, here we would have x minus 3, x plus 3, then we would have the last one plus x minus 3 into bracket x squared plus 3x plus 3 squared is equal to 0. We have x minus 3 here, x minus 3 here, and x minus 3 here. We can factorize. So we say x minus 3 into bracket. What will be left here is 1. So I'll say 1 plus what is left here is x plus 3. And then what is left here is all of this. So we say plus x squared plus 3x plus 9 is equal to 0. To tidy this up, we are going to have x minus 3, then 1 plus 3, that's 4, then plus 9, that's 13, then plus x here, plus 3x, that's 4x, then plus we are left with x squared is equal to 0. We can rearrange this to give us x minus 3 in order of the power of x. This is x squared plus 4x plus 13 is equal to 0. So this is either x minus 3 is equal to 0 or x squared plus 4x plus 13 is equal to 0. From the first part here, we see x is equal to 3. And then from the second part, we'll need to solve this quadratic equation. We're going to use the general quadratic formula, and from here we need to find the coefficient of x squared, the coefficient of x, and then the constant term. A here is 1, B is 4, and C is 13. Let us find the discriminant. The discriminant tells us the nature of the root of a quadratic equation. So for this equation, if the root is a real value, then we can proceed the same way we'll proceed with this one. But if it is complex, that is less than 0, being negative, we will not be able to find an actual solution for this problem. So the discriminant is given by the formula b squared minus 4ac. Therefore, d is equal to b squared. B is 4, so we have 4 squared, then minus 4, a is 1, then c is 13. So d is equal to 4 squared here is 16, then 4 times 1 is 4, 4 times 13 is 52. Obviously, 16 minus 52 is a negative value. So we are going to ignore this process and face this. Recall that we said let 2 raised to power m be represented by x. So at this point, 2 raised to power m is now equal to 3. To solve for m, which is the actual variable we are looking for, I'll take the logarithm of both sides. So I have log 2 raised to power m is equal to log 3. And by logarithm, given log p raised to power a, this is expressed as a log p. Therefore, this is going to be m log 2 is equal to log 3. I'll divide both sides by log 2. So that we get m is equal to log 3 divided by log 2. And by logarithm, log a divided by log b is always equal to log a base b. So m becomes log 3 base 2, which is our final answer to this problem. Let us now check to see that this solution is correct. We'll substitute our new solution, log 3 base 2, into the actual problem, which was 2 raised to power m plus 4 raised to power m plus 8 raised to power m is equal to 39. This will imply 2 raised to power log 3 base 2 plus 4 raised to power log 3 base 2 plus 8 raised to power log 3 base 2 is equal to 39. This will be 2 raised to power log 3 base 2. 4 here is 2 raised to power 2. Then raised to power log 3 base 2. And 8 here is 2 raised to power 3. Then raised to power log 3 base 2 is equal to 39. If I return these powers to, I can return these powers to here so that I have 2 raised to power log 3 base 2 plus 2 raised to power. So returning this becomes 3 squared, and 3 squared is 9, so I have 2 raised to power log 9 base 2. Doing the same thing here gives me 2 raised to power log 27 base 2 is equal to 39. At this point, we can apply this law of logarithm. X raised to power log m base x will give us m. So this expression right here will give us 9. And this expression right here will give us 27. And when put together, this expression also will give us 3. Therefore, we would have 3 plus 9 plus 27 is equal to 39. This is 12 plus 27 is equal to 39, giving us 39 is equal to 39, confirming that our solution is correct. Thanks for watching. Please like and share and subscribe to my channel. I'll see you in my next video.